Hello everyone, welcome back to our channel. In today's video, we will be discussing our new weekly lesson. So this will be equivalent to 4 days. This is under our subject probability and statistics. And we will be discussing the two competencies under our curriculum guide of probability and statistics. The first competency would be interprets the mean and variance of discrete random variable. And the second would be solves problems involving mean and variance of probability distributions. So I hope that you will be enjoying in this video lesson. So let's get started. Welcome back to our channel. In today's video, we will be discussing our third week lessons. So we're gonna start with the lesson objectives. Lesson objectives for day 1. By the way, these lessons would be the entire week, so that would be from day 1 to day 4. So let's start with the knowledge. Familiarizes the formula in solving the mean and variance of probability distribution. Under the skills, computes and interprets the mean and variance of a discrete random variable. And for effective, develops patience and perseverance in computing and interpreting the mean and variance of discrete random variable. So this is just in connection with the previous week lesson. So interpretation and the computed mean and variance of random variables. Now in last week's discussion, you know already how to solve for the mean and variance of random variables. Now this time, we will proceed to interpretation, but still we are going to recall and still going to solve for the mean and variance of random variables. We will have few examples later on. So by the way, instead of oral recitations, since this is presented on a video lesson, I want you to answer in your notebook. Matching type test. The direction is match column A with appropriate description of definition in column B. So I want you to write this on your notebook, this table, and then you will just write the letter before the number. Okay, or you could also match, like here you can connect to anywhere, any letter that corresponds to the appropriate description of these concepts here. So for column A, we have here random variable, number 2 discrete variable, number 3 continuous variable, number 4 probability distribution, number 5 mean, number 6 expected value, number 7 variance. And for column B, letter A, distribution of the probability of all the possible values. Letter B, considered as a measure of the central location of a random variable. And letter C, can be computed by first multiplying each possible x value by the probability of observing the value and then adding on the resulting quantities. And letter D, values obtained by counting. Letter E, a weighted average of the values that random variable x can take. Letter F, values obtained by measuring. Letter G, calculated by getting the sum of the product of the square of variable x and its probabilities, then subtracted by the square of the mean. And letter H, lastly for letter H, a variable whose value is a numerical outcome of a random phenomenon. So let's have an activity. Okay. So I want you to answer this one. Of course, this individual. Do it in your notebook. So you have the first one after the matching type. You're going to do this activity. The instruction would be, I will let you ask your classmates on the average daily allowance last week. Then you're going to construct a probability distribution table. By the way, I want you to limit at least 10 classmates, okay, on their average daily allowance. So by the way, I will know if you will have the same answer. So I expect that no two students will have the same output or the same sets of students that would lead to the same probability distribution table. So you have to make your own. This is individual. Okay. Now construct a probability distribution table. So this will have an example. So below is the data of the average allowance per day of the senior high school department. So if our x here, the random variable x, we have, for example, 20 is the allowance, and there are 13 students whose allowance is 20, and then we have 6 students whose allowance is 25 pesos, 11 students whose allowance is 30 pesos, there are 7 students whose allowance is 40 pesos, and 3 students whose allowance of 50 pesos, and the total of frequency would be 40. So that's expected that there are 40 students in a class, and the probability of the random variable x would be, that is 13 over the total number of frequency, that is 13 over 40, or 0.325 thousandths. Then we also have 6 over 40, or 0.15 hundredths, 11 over 40, or 275 thousandths, 7 over 40, or 175 thousandths, then 3 over 40, or 75 thousandths. Then you will have here a total of 1. Okay, that's why it's a probability distribution table. Okay, let's continue. So compute the mean of the probability distribution. You know already the formula for the mean. You have this one, the summation of x sub I times p of x sub I. Then you will have 20 times 0.3325 plus 25.015 plus 30 times 0.275 plus 40 times 0.175 plus 50 times 0.075. Then the answer, it would be 29.25. So what would be the interpretation? Okay, how we're going to interpret the result? So this is how you're going to interpret the result. You will say, therefore, the mean of the average daily allowance of the students last week is 29.25. Now, the previous activity, I told you that you are going to ask your classmates, and at this 10, you will come up with your own. You will create your own probability distribution table. And later on, you will also solve for the mean. Okay, let us proceed to another example. Example number 2. So suppose you own a sari-sari store. The probabilities that a customer will buy 1, 2, 3, 4, and 5 items from your sari-sari store are 2 over 10, 1 over 10, 3 over 10, 3 over 10, and 1 over 10 respectively. So you will come up, what is the average number of items that a customer will buy? So you're going to come up with a probability distribution table, or you will just simply solve it like this. Okay, so the mean or the expected value, this is the formula, summation of x times p of x, then 1 times 2 over 10 plus 2 times 1 over 10 plus 3 times 3 over 10 plus 4 times 3 over 10 plus 5 times 1 over 10, and the answer would be, okay, that's 1 times 2, that is 2, then divide by 10, that is 0.2. 2 times 1 is 2 over 10, that's still 0.2. 3 times 3 is 9. 9 divided by 10 is 0.9. 4 times 3 is 12. 12 divided by 10 is 1.2. 5 times 1 is 5. 5 divided by 10 is 0.5. Okay. Then we're going to add. The answer is 3. So what would be the interpretation? You will say, therefore, the average number of items that your customer will buy is 3. Okay, as simple as that. I hope that you were able to follow from the start. Okay, let's continue. Let's proceed to another example. Example number 3. The probabilities that a surgeon operates on 3, 4, 5, 6, or 7 patients in any day are 0.15, 0.10, 0.20, or 0.25, and 0.30 respectively. find the average number of patients that a surgeon operates on a day. So you will have this expected value or mean is equal to x sub 1 times p sub 1 plus x sub 2 times p sub 2 plus and so on and so forth times x sub k times p sub k. Okay, so you have this mean is 3 times 0.15 plus 4 times 0.10 plus 5 times 0.20 plus 6 times 0.25 plus 7 times 0.30, and you will have the result 0.45 plus 0.40 plus 1 plus 1.50 plus 2.10, and the answer is 5.45. So how are we going to interpret this one? Okay, you will say, therefore, the average number of patients that a surgeon operates in a day. Okay, or therefore, the average number of patients that a surgeon operates in a day is 5.45. Since there's no decimal place, you will say 6. You are going to round it off because we're talking about number of patients, so there must be no decimal number of patients. So you're going to round it off to the nearest whole number, which is 6. So therefore, the average number of patients that a surgeon operates in a day is 6. Okay, so there must be 6 here. Next, so example 4, the data on the number of storms for the past 3 decades. This is your table. This is your year from 1991 to 2000, and this is the x. This is the number of storms per year or within a year. Then from year 2001 to 2010, then this is your x, which is the number of storms. And in the year from 2011 to 2021, and this is your corresponding number of storms per year. Okay, so you have here 3 decades, because when you say decade, 1 decade is equivalent to 10 years. So this is 10 years, another 10 years here in this column, another 10 years, a total of 30 years or 3 decades. Now we are going to come up with a distribution table, probability distribution table. So if you have your x, so take note that we write 32, that is our x, 32, 31, 28, but if it happens that one of these x's repeats, so we're just going to write it once. Okay, so which among the values of x that repeats? 32 doesn't repeat. How about 31? How about 31? We have 31 here, we also have 31 here. It repeats, so we're just going to write it once. Okay, so we will have like this. So 32, 31, since 31 repeats twice, so you will have our p of x, which is 2 over 10. So 32, then 1 over 10. Then 31, that's 2 over 10. Then 28, 1 over 10. 36, 1 over 10. 30, the probability is 1 over 10. 11 is 1 over 10. 16 is 1 over 10. 20 is 1 over 10. 23 is 1 over 10. So once the number of storms in that particular year does not repeat, so the probability is always 1 over 10, because there are 10. This total number of years is 10 in every 1 decade. Okay, so it's a group of 10, except for this, that there are two years wherein they have the same number of storms, which is 31. Now let us proceed to the next one. So we'll start with this one, 25, 26, 21 until 19, and we're going to write it once. If it repeats, we're going to write it once. Okay, so you will have, by the way, we're still going to multiply. We need to get the product of our x and px. So we will have 32 times 1 over 10 is 3.2. 31 times 2 over 10 is 6.2. 28 times 1 over 10 is 2.8. 36 times 1 over 10 is 3.6. 30 times 1 over 10 is 3. 11 times 1 over 10 is 1.1. 16 times 1 over 10 is 1.6. 20 times 1 over 10 is 2. Then 23 times 1 over 10 is 2.3. Then next would be the next decade. So we're going to write the x, the random variable, 25, 26, 21, 29, 23, 14, 22, 19. And the corresponding probability is 1 over 10, 1 over 10, 1 over 10, 1 over 10. And 23 repeats twice, so that's 2 over 10. Then here is 1 over 10. 22 repeats twice, so you have 2 over 10. Then 19 is only 1, so you will have 1 over 10. Then the product, 25 times 1 over 10, that's 2.5. 26 times 1 over 10 is 2.6. 21 times 1 over 10 is 2.1. 29 times 1 over 10 is 2.9. 23 times 2 divided by 10 is 4.6. 14 times 1 over 10 is 1.4. 22 times 2 over 10 is 4.4. The 19 times 1 over 10 is 1.9. Okay, let us proceed to the third group. So we will have the x would be 21, 25, 31, 23, 27, 26, 22, 29. These are random variable. And then, since 21 repeats twice, there are 2 years in which 21, the number of storms in that particular 2 years is 21. Okay, so they share a common number of storms. So you will have 2 over 10, I mean. Then 25 is 1 over 10. Then 31 is 1 over 10. For 23, 2 over 10. 27 is 1 over 10. 26, the probability is 1 over 10. 22 is 1 over 10. Then 29 is 1 over 10. Then you multiply 21 times 2 over 10, that's 4.2. 25 times 1 over 10 times 2.5. 31 times 1 over 10, that's 3.1. 23 times 2 over 10, that's 4.6. 27 times 1 over 10, that's 2.7. 26 times 1 over 10, that's 2.6. 22 times 1 over 10, that's 2.2. 29 times 1 over 10, that's 2.9. Okay, so I hope you understood the manner on how we come up or construct this table. Okay, so let us continue. Now to solve for the mean, all you have to do is add. Look at that. Okay, so you have 3.2 plus 6.2 plus 2 until 2.3. Okay, this one, we add all this. So the answer is 25.8 or 26. So if ever we are asked to the data and number, if we are asked what would be the average number of storms in a year from in the first decade from 1991 to 2000, so the answer would be this one, 25.8 or 26. We're going to round it off. So 26 would be the average number of storms in the first decade from 1991 to 2000. Okay, let us proceed to the evaluation. This is for individual. Now I want you to compute the mean random variable x, the number of siblings among your 7 closest friends in the class. Now what is your interpretation of the mean? And what is the average number of siblings of the class? Now, again, you are provided with this template, this table. You are going to copy this in your notebook. And take note that I expect that you will have different answers from your classmates. Okay? No 2 answers must be the same. Okay, so we're done with the day 1. Now let's proceed to the day 2. Okay. Let's start with the lesson objectives. Under knowledge, you have familiarizes the formula in solving the mean and variance of probability distribution. Under the skills, computes and interprets the mean and variance of a discrete random variable. Under the affective domain, develops patience and perseverance in computing and interpreting the mean and variance of discrete random variable. Now, interpretation of the computed mean and variance of random variables. So let's have a quick recall. You have compute, average, interpret, mean. We have random, we have variable, we have distribution, we have variance and probability. We also have discrete. Okay, now we tackled all those concepts already in our previous videos. So let's start with the discussion. Now, the variance of a discrete random variable x measures the spread or variability of the distribution. Now, the variance usually denoted by the symbol, this one, and is also denoted as var of x, and formally defined as this one. Okay, can have the symbol or var of x, or it could be the formula, summation of x of I minus the mean quantity squared times the probability of I. Now, or can be written this way. You can have this way, or the other way, this one. Okay, so I know that you are familiar with already familiar with the formula of the variance as well as the mean, because we kept on repeating this lesson, you know, because the moment we discuss on interpretation, we also recall the formula. Now, the variance gives a measure of how far the values of x are from the mean. Now, let's start with the example. The time to the nearest whole minute that a city bus takes to go from end of its route to the other has the probability distribution shown below. Now, the probabilities shown in the table add up only to a value other than 1 because rounding off error. Okay, now finding the average time the bus takes to drive the length of its route. So you have here the probability distribution table. You have here x is 77 with probability 0.15, x is 78 with probability of 0.15, then we have 79, probability is 0.40 with 80, probability is 0.20, then 81, the probability is 0.10. So since we are asked to find the average time the bus takes to derive the length of its route, we need to get the expected value or the mean. So we have here the mean or the expected value of x. We have this formula, x sub I times probability plus x sub 2 times probability plus and so on and so forth. Okay, continue. So you will have this mean is 77 times 0.15 plus 78 times 0.15 plus 79 times 0.4 plus 80 times 0.2 plus 81 times 0.1. Then you'll have 11.55 plus 11.7 plus 31.6 plus 16 plus 8.1. Then you will have 78.95 or 79 minutes. So that is now the answer. Okay. Now, this is how you're going to interpret. Therefore, the mean or average time the bus takes to derive the length of its route is 78.95 minutes. When rounded off to the whole number, minutes is 79. Okay, let us proceed to example number 2. Find the variance of the length of the time the bus takes to drive the length of its route. So we are asked to find the variance. So you will have this formula. Okay, the variance is 77 minus 79 quantity squared times 0.15 plus 78 minus 79 quantity squared times 0.15 plus 79 minus 79 quantity squared times 0.4 plus 80 minus 79 quantity squared times 0.2 plus 81 minus 79 quantity squared times 0.1 is equal to 0.6 plus 0.15 plus 0 plus 0.2 plus 0.4, a total of 1.35. Okay, so how we're going to interpret the variance. So we have here the interpretation. Small variance or standard deviation means that the assumed values or data points tend to be very close to the mean. The next, higher variance or standard deviation means that the assumed values or data points are spread out from the mean. Then third, we have the variance and standard deviation measures or describes how far a set of data, assumed values of random variables, is spread out. Okay, now computing the standard deviation, if our variance is 1.35, our standard deviation will be the square root of the variance, that is 1.16. Therefore, the variance is 1.35. Since it is too small, it means that the data points tend to be very close to the mean. So this is now the interpretation. Okay, we can say that the assumed values of each outcome are somewhat close to the mean for about 1.35 units from the mean. Now, so if you're going to plot the graph, this is how it will look like. This is our probability. This is our random variables. We have x is equal to 77. These are number of minutes. X is equal to 79. X is equal to 78, then 79, then 80, then 81. And this is our mean. No, standard deviation, which is 0.35. Okay, let's continue. This is just plotting the graph. We cannot see the mean here. This is just simply plotting the graph. This is our random variable x, and then this is our equivalent probability distribution. Okay. Now, under developing mastery from the result in computing the mean number of siblings in class, remember the last time when I asked you to compute the mean number of siblings in a class and compute also the variance and interpret. So you have to continue that because you're done with your previous activity. I think that's day 1. So you are going to compute the mean number of siblings in class as well as the variance. Then you are going to do the interpretation. Then how does the assumed value of the outcome vary from the average number of siblings of the class? You're going to answer that. Now let's proceed to the application. Give us many examples of the real-life applications of discrete random variable as shown in each place. Okay, so you're going to answer this on your notebook again. So for example, at home, just provide at least two examples of each. So you are going to give 2 examples of discrete random variable that which you can see at home, in the market, in the hospital, in the carnival or circus. Okay. Now let's proceed to generalization. First question, how are you going to compute the mean of discrete random variable? Second, given the mean and variance of discrete random variable, how are you going to state your interpretation? Okay, let's proceed to evaluation. Okay, you are given a situation. A group of senior high school students was tasked to conduct a survey on the number of pets they have at home. Now, I know that most of you have pets. Like, it could be mostly dogs, or you get puppies, but others also are cat lovers. Okay, so you have here below is the probability distribution for y, the number of pets they have at home. So you have to complete the table by supplying the desired data of the questions. The table is here, so all you have to do is, okay, you are given already the values of y, the random variable y, the number of pets they have at home. This is your y. Okay, this is number of pets your classmates have at home. So for those who have, that's from 0 to 5 number of pets. And example, there are 5 students who has 0 pets at home. Then there are 4 students who got 1 pet at home. Then 6 students who got 2 pets at home. 8 students who got 3 pets at home. 1 student who got 4 pets at home. Another 1 student who got 5 pets at home. Okay, then you are going to continue or complete this table, and you are going to answer the following questions. What is the average number of pets and the students have at home? Interpret your answer. Again, what is the average number of pets the student have at home? Then interpret your answer. Now, letter B. How does the assumed value of the outcome vary from the average number of siblings of the class? Okay, assignment. Think of real-life problems involving the mean and variance of a discrete random variable for us to solve the next day or later. Okay, so let us proceed to day 3. Okay, for day 3, recalls under knowledge, recalls the formula in solving the mean and variance of probability distribution. Under the skills, solves problems involving the mean and variance of a discrete random variable. And affective gives the importance of solving and interpreting mean and variance of a discrete random variables through real-life situations. Now, solving problems involving mean and variance. So let's start with the first example. Now, a researcher conducted a survey on the number of items a customer buys in a bookstore. Below is the result of the researcher's survey. The probabilities that a customer will buy 1, 2, 3, 4, and 5 items from a certain bookstore are 0.6, 0.28, 0.07, 0.03, and 0.02 respectively. First question is you have to create a probability distribution table. Letter B, find the mean and variance of the survey, and letter C, give your interpretation. Okay. So using the formula for the mean, so you will have this formula. So you're going to solve. That's 1 times 0.6 plus 2 times 0.28 plus 3 times 0.07 plus 4 times 0.03 plus 5 times 0.02. Then you have your 0.6 plus 0.56 plus 0.21 plus 0.12 plus 0.1. A total of... Okay. By the way, this is your probability distribution. This is now the table that you come up. Let's continue. Okay, this is the answer for letter A, by the way. Your x is 1 to 5. Then P of x is 0.6, 0.28, 0.07, 0.03, 0.02. And then this is our mean. And this is now the total. This is our mean, our expected value, which is 1.59. Then for letter C, we are asked to solve for the variance. The formula of the variance is this. Then for simplified computations, the formula for variance is this one, 2. So you will have 1 squared times 0.6 plus 2 squared times 0.28 plus 3 squared times 0.07 plus 4 squared times 0.03 plus 5 squared times 0.02 minus 1.59 squared. Okay, so we have 0.6 plus 1.12 plus 0.63 plus 0.48 plus 0.5 minus 2.5281. Then the answer is 0.8019. Okay, if asked to solve for the standard deviation, just the square root of the variance. You have this is your variance, then the standard deviation would be the square root of this. Square root of 0.8019 is 0.90. So that it would be our standard deviation. Now, for interpretation in letter C, you will say the mean is 1.59 or 2. This means that the average number of books the customer bought in a bookstore is 2. Now, the variance is 0.8019, which indicates that the data points or set of data is too close to the mean, which is 2. Okay, example 2. Okay, I hope that you understand problem number 1 as our example. Okay, now let's proceed to example number 2. A statistics and probability teacher conducted his modular class on a 0, 1, 2, or 3 days in a week. The probability that he holds a class on a 0 day is 0.35. The probability that he holds a class on 1 day is 0.25. The probability that he holds a class on 2 days is 0.30. And the probability that he holds a class on 3 days is 0.10. Now construct a probability distribution table, then find the average or expected value, which is or the mean of the number of days per week that the teacher holds modular class. Give your interpretation. Okay, so we'll have this one probability distribution table. We'll start with a table. Our x is 0, 1, 2, 3 with a probability, corresponding probability is 0.35, and the product of the random variable x to the probability is 0. Then if x is 1, our p of x 0.25, that's probability. 1 times 0.25 is 0.25. If our random variable is 2, then our probability is 0.30. they have 0.6. That is 2 times 0.30 is 0.6. Then 3 times 0.10 is 0.3. Probability is 1. So that proves that this is our probability distribution table. And the product, the sum of the product here is 1.15. Therefore, the expected value of mean is the summation of the product of x and p of x. So you will have 0 times 0.25 plus 0.6 plus 0.3, a total of 1.15. Okay, so we're done answering letter A and B. Now let's proceed. Therefore, the expected value of mean is 1.15. This means that the statistics and probability teacher would, this is now the interpretation, on the average expects to hold modular class is 1.15 days per week. The number 1.15 is the long-term average or expected value if the statistics and probability teacher holds modular classes week after week after week. Okay. Now let us proceed to, okay, so we're done with problem number 2. Okay, now we are now on the 4th day. So let's start with the knowledge. Let's start with the objectives. So recalls the formula in solving the mean and variance of probability distribution, solves problems under scale, solves problems involving the mean and variance of a discrete random variable, and for affective gives the importance of solving and interpreting mean and variance of discrete random variables through real life situations. Okay, so developing mastery, the situation will be the number of inquiries, for example. So the number of inquiries received per day by the office admissions in a certain university is shown below. Find the mean, variance, and standard deviation of the distribution. X is the random variable which stands or represents the number of inquiries, and P of X is the probability of the particular random variable X. So if there are 22 inquiries, the probability is 0.08. 23 inquiries, we have 0.19. 24 inquiries, we have 0.36 as the probability. Then 25 inquiries, we have 0.25. 26 inquiries, we have 0.07. Then 27 inquiries, the probability is 0.05. Now for generalization, I want you to answer this in your notebook. Answer the following. What is the formula in solving? Okay, by the way, since this is developing mastery, you have to answer those in your notebook. You have to find the mean, the variance, and standard deviation. Okay, if under the generalization, what is the formula in solving the mean, variance, and standard deviation of discrete random variable? Second, how are they stated in the interpretation part? The mean, the variance, and standard deviation. Then, let's proceed now to the evaluation. You've noticed that on day 4, this is more likely you're asked to answer because from day 1, day 2, and day 3, you are given plenty of examples already. That's enough for you to answer day 4. Now, the situation would be like this. So, it goes this way. In a hamster breeder's experience, the number X of live pups in a litter of a female not over 12 months in age who has not born a litter in the past 6 weeks has the probability distribution. This one. You have here X, the number of live pups, 3, 4, 5, 6, 7, 8, 9. And then you have this probability. You have your probability, corresponding probability is 0.04. Then 0.10, 0.26, 0.31, 0.22, 0.05, 0.02. Then, these are the questions. Number 1, solve the mean, variance, and standard deviation of X using the formula. Number 2, construct a complete probability distribution table. So, you have to add this table. And number 3, give your interpretation of the result. You are taught already how to provide the interpretation. Okay. And for your assignment, have a research on the following. Define the following terms and phrases. Letter A, normal random variable. Letter B, normal curve. And number 2, what are the characteristics of a normal or random variable? And be ready for the discussion for next week. Okay, so thank you so much. I hope that you were able to learn something in today's video. And by the way, thank you so much for subscribing my channel, and I hope that you won't skip ads once you're watching this video lesson. Thank you so much, and God bless us all. Bye!